Okay, hello everyone. In a new video, so I have reached part 1 of chapter 7, which is Newton's second law for grade 11 students. Then let me write here the title, chapter 7, which is given by Newton's second law. And let me directly start with the first section, which is section number 1, the force. As we mentioned previously, that the force is a mechanical action, exerted by a body on another. So this is the physical definition of the force. As for the mathematical definition, simply the force is represented by vector F. And let's start by section number 2, or continue by section number 2, which is types of forces. A force F can be classified as a contact force or force acting from a distance or acting at a distance. So the forces that act at a distance are simply given by three forces. We have the weight, electric force, and magnetic force. All other forces So what about the contact forces? All other forces are classified as contact forces. So why the classification of a force is important? Let me make the following note. The classification of a force is important in order to determine the point of application of a force of the given force. So contact forces have point of application, which is the point of contact, between the two bodies that are at interaction. So notice that contact forces have point of application, which is simply given by the point of contact between the two bodies that are at interaction. Now, as the force is acting at a distance, have point of application the center of gravity or the center of mass of the body. So for this reason, previously in chapter 6, we have discussed the barycenter formula, which allows us to determine the center of mass. The center of mass or the center of gravity plays an important role in identifying the point of application for forces acting at a distance, and this is very important, not for this chapter, but for the coming chapter, in which we will discuss the moment of the force. In this case, the point of application of the force plays an important role. And now let's discuss the properties of the force of a force. So the properties are given by the Pilldam, and they are the point of application, line of action, direction, and the magnitude. Okay. Now let's start discussing the forces, and let's start by the first one, which is given by the weight. So section number 4, the weight. It is the force exerted by Earth on any object. So notice that this is the physical definition of the weight, not the mathematical one. So here, if we recall back, we have introduced the force in two manners. The first one is given by the physical definition, and the other one is given by the mathematical definition. So for the physical definition, it is the force exerted by Earth on any other object. Okay, now let's start by the mathematical definition. So the weight is a force acting at a distance. So the point of application will be center of mass or center of gravity, G, and we know that always the weight acts vertically downward, independent of the scene. Now in most of the cases we will be working in two dimensions. So the magnitude of any vector W, which is given by Wxi in the vector notation, plus Wyj. So we drop down the vector and the magnitude W is given by square root of Wx squared and Wy squared, knowing that the unit of W is in newtons. So the magnitude gives us information about the strength of the force. Moreover, the weight can be directly calculated if we know the mass and we know the gravitational field strength, because W is equal to m multiplied by g. So this is the magnitude of the weight, expressed in newtons. M is the mass expressed in kilograms, and G, gravitational field strength, expressed in newtons per kilogram. So, considering the following important remark: whenever an object has a mass, it will be directly subjected to the weight, which is the force exerted by the earth on this object. Now let's move to the next force, which is the tension. So section number 5, tension denoted by the T vector. So it is the force. Let's start by the physical definition. It is the force exerted by a string or a spring on a given object. Then for this reason, let's consider the following scene. So suppose here we have a solid S connected So here we have a solid S connected to a string. So suppose that this solid has a mass m. So it will be directly subjected to the weight, which is acting vertically downward like this. Now, because the weight is classified as a force acting at a distance, so it will be acting at the center of gravity of the solid S, which is a G. So now, because the weight causes an action on the solid S, we expect the solid S must fall down. But what's preventing the solid S from falling down is the existence of the tension force along the string. So suppose this is the point A, which is the point of contact between the solid S and the string. Therefore, another force will be exerted on the solid S, which opposes the action of the weight, and this force is given by the tension T. So now let's write the properties of the tension T. So the point of application, so in order to determine the point of application, it's important that we start by classifying the force itself. So notice that the tension T is not electric, nor weight, nor magnetic. So it's not a force acting at a distance. Therefore, the classification of this force is a contact force. Then the point of application will be the point of contact. A. Now, as for the line and action and the direction, these are very important. So always the line of action of the tension is along the string, and in this case the direction of the line of action of the string is vertical. So the line of action is vertical, along the string vertical. And now the direction is away from the body. So in this case it is upward. So always the direction of the tension is away from the body, and away from the body in this case it is upward. Now as for the magnitude, so we drop down the vector. Suppose that the t vector is given by txi plus tyj, represented in an orthonormal system. And then the magnitude t, we drop down the vector and we take the square root of the components. Okay. Now the aim of this chapter is to determine this magnitude, the magnitude of an unknown force, using Newton's second law. So this is it for the tension T. And now let me make the following remark. So this is the string in this case. The types of strings or ropes that we consider are inextensible strings or ropes. Okay. And what do we mean by the word inextensible? This is very important. Okay. Now let's consider the following. Suppose that we have a support, and connected to this support we have a pulley. Now passing through this pulley we have two strings. We have one string like this, So suppose here we have a solid S, and here we have another solid which is given by B. Okay, and the string is wound around the pulley like this. So this is said to be a pulley, and this is the support. Now notice that for the solid S, the weight is acting vertically downward like this. So let's say that this is the weight of the solid S, and because here we have a string, then there must be another force opposing the action of the weight, which is the tension, say for example T1, or let me say that this is the object 1 and this is the object 2. Now so we have here W1 acting on the object 1, and we have the tension T1 acting also on the solid 1. Now for the object 2 we have another weight W2 acting on the solid 2, and because we have a tension there must be another tension force. So suppose that this is the point A and this is the point B, this is G1 and G2. The tension T2 will be acting at the point B vertically upward like this. Now the thing is that in magnitude the tensions T1 and T2 are equal, and this is because, and this is due to the fact that the string around the pulley is inextensible. And this is due to the fact that the string around the pulley is inextensible, and by this, so inextensible strings uh, transmit tension equally on both sides of the string. So the tension T1 here at the free end of the spring at the point A is equal to the tension T2 at the free end of the string at the point B. Here we are saying in magnitude because sometimes the other properties, so for example here say that the point A and the point B, they are not equal. So here the line of action and the direction for both forces are equal, but in other cases it may happen that the line of action and the direction of T1 and T2 are not equal. Okay, so always we consider a special type of strings that are inextensible strings that transmit tension equally on both sides of the string. It's me on the on both sides of the string. And here by both sides of the string I mean the free end of the string. Let me say on the free end of the string. Okay, so this is it for the tension. Now Later we will discuss more the fact of the inextensible strings. Now let's move to the reaction at the support. Now suppose here we have a support and we have a box or a solid as resting on this support, and let's suppose that this is the point A, the point of contact between the solid as and the support, and let's say that the point G is the center of mass or the center of gravity of the solid as. So we know that because the solid as has a mass, then it will be directly subjected to the weight, which is vertically downward like this. And in order to explain why the solid as is not falling down, we need to introduce a new force, which is called the reaction of the support. So what are the properties of the reaction at the support? So let's start by the point of application. Now, because the reaction at the support is not electric, nor weight, nor magnetic, then it's classified as a contact force, which means the point of application is the point of contact between the two bodies that are at interaction, and this is given by the point of contact A. Now, as for the line of action, perpendicular to the support, so in this case it's given by vertical. Now the direction, in this case it's opposing the action of W, so the direction will be upward. So now we are ready to draw the reaction of the support. So it will be something like this. So as for the magnitude, so the magnitude, if R is represented in an orthonormal system, so it's given by its x component multiplied by the unit vector I and ry multiplied by the unit vector j. So it's simply given by R, which is equal to the square root of Rx square plus Ry square, and for sure the unit of R is also Newton because it's force, magnitude of a force. Okay, and now let's move to the other force, which is the friction force, which is the last force in this section, or in this part. And here, I didn't write the physical definition of a force. Let me write it here. It is the force exerted by a support being in contact with a solid as. And the mathematical definition is given by these properties. Now, as for the friction force, it is the force that opposes the direction of motion and it exists whenever the surface of contact between the two bodies is rough. And by rough we mean, or it means not smooth. So this is the physical definition of the friction force. Now, in order to explain what is meant by friction force, let's consider the following scene. Suppose that we have an inclined plane like this, and let's suppose that this surface here, so suppose that this is the point A and this is the point B, and let's say that AB is a rough surface, and suppose in this case we have placed a solid S on this rough surface, and now let's list and represent the forces acting on the solid S. Because the solid S, for sure it has a mass, then it will be directly subjected to the weight which is vertically downward like this. So this is the weight. Now because we have a support, then it will be subjected to the reaction at the support which is perpendicular to the support. This is perpendicular to the support, and because it's a contact force, then the point of application will be the point of contact between the two bodies that are at interaction. Now because here we have a rough surface, then we will have the force of friction. So let's start by listing the properties of the force of friction. So the point of application is the point of contact A, because the rough surface is between the solid S and the rough surface AB, and they have a point of contact A. So the line of action will be, so okay, the line of action is, let's say, along the support, and the direction opposing the direction of motion, and we will discuss the magnitude now. So notice that till this moment I didn't specify the line of action and the direction. So how to specify the line of action and the direction of the friction force? Now suppose that if we don't have a friction, so the solid S, in this case, S is not moving. So S is resting on the plane like this. So suppose that S, because it's being acted by the weight which is acting vertically downward, so we expect S that must fall along the inclined plane AB. So in this case, the direction of motion of S will be like this, along AB, okay? So always the line of action and the direction of F is opposite to that of motion. So first of all, we specify the direction of motion. So this is the direction of motion. Then in this case, the line of action and the direction of S will be simply like this. So this is the force F, but here we need to be very careful because F will be represented along the point A. So for this reason I have mentioned point of contact A along the support opposing the direction of motion. So this is the direction of the force F. Let me represent it in blue. And the magnitude of this force is given by, so suppose that F is equal to Fxi plus Fyj. So simply we drop down the vector and the magnitude of F is given by square root of Fx squared plus Fy squared, okay? And now, so after we have introduced all forces, let me start by section number 8, which is given by Newton's second law. Okay, which is given by, okay, so Newton's second law. Then in Newton's second law, so we usually write it like this, Newton's second law, or this is also referred to the fundamental principle of dynamics. So say in translation, is given by sum of forces is equal to ma. So what does each quantity represent? Let's start by the sum of forces. The sum of forces acting on a body, on a given body. M is the mass of the given body and for sure the SI unit of mass is kilogram. Here this is Newton, and we know what's meant by A. A is the acceleration. For sure it is a vector quantity. If you are interested in the magnitude, then we can say that A is equal to square root of ax squared plus ay squared. So is the acceleration of the given body. For sure in the SI it's expressed in meter per second squared. Okay, so that's it for me in this video, guys. And the next part 2, we will discuss how to apply Newton's second law, what are the different steps, and how do you solve this vectorial equation. For sure we know that using the projection method, and we will discuss also the fact of the inextensible strings. Okay, so see you soon in a new one.